Hello guys, this is Apex and it's fucking 6 in the morning and I can't sleep. So, not having anything better to do, I thought I'd share this little video. This is a video about the gemming in Archeage, which I'm sure you're all familiar with. Gemming can be a very rewarding activity to do when you finally get that fifth or that sixth or seventh gem into a piece and maybe fully gem it, or you have one just getting six gems in. Just it's an extremely good feeling. It's like looking out with a regrade. And then you have people that happen to that. I have some friends that sometimes when they've gemmed several pieces to full with very few gems, and then you have people with my luck. And I have spent I had a pair of breeches that I spent 180,000 honor to. I was trying to fully gem it. I think it had 6 or 7 slots in it, and I spent 180,000. I wasn't able to do it, and since seeing as a gem costs like I think it's 770 honor, that's like yeah, what is it? 250 gems. So with 250 gems, I wasn't able to get. It was either 6 or 7 gems into it, and I ended up having 3 or 4. So some people are lucky with it, some people are not. But that's not what I came here to talk about. Because we sometimes get into the discussion of what is the statistical chance of getting X amount of gems into a piece. And here there are a lot of different theories. Mm, I've heard several people talk about it, and they say it's a one in a blah 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 chance. And I disagree with a lot of them because Platinum and I once did a calculation of how many gems was needed for each stage, getting to one, not one, but two and three and four and five and six and seven. And we think that this is the correct way. This will give you the best image of how many gems is needed. So I'm not sure how other people are calculating it, but I think this is the correct way, and I think they've simply overlooked some things. So yeah, I think this is the correct and most accurate way to determine it. So 2 rules before we get started here. Number one is that we're assuming the first gem always works. It has a 100% chance. Uh, the reason why I'm making that a rule is because I've heard some people say that the first gem has a super tiny chance of actually breaking, like a 1 in 100, a 1 in 1,000 chance of breaking. And I'm not sure if I believe that because I've probably I've probably used a couple of thousand gems, and I don't think I've ever seen a first gem break. So I have trouble believing that. But either way, it's such a small chance that it won't affect this too much. But if it was true, then the math here would be slightly off because because we're not taking that into consideration. We're assuming the first gem always works. Rule number two is that we assume that putting each gem on, except the first one, has a 50% chance of working. That's what we feel is accurate, that's what most people think, and I've never done such a test to get 10,000 gems and try to socket them and see how many breaks and how many don't. So I can't say that 100% for sure, but that's what we're going out from here. It could be, 45 to 55% chance or 55 to 45. At least I think they're extremely close. But here we're assuming it's 50-50. So, that in mind, I'll show you how I think this is calculated correctly, and of course this is just mathematically speaking the statistical amount of gems you need to get to each point 3, 4, 5, 6 gems. You can of course luck out and put 7 gems in using only 7 gems, or maybe just 10 gems, or just a very low amount. Or you can be super lucky and spend hundreds of gems and not be able to get 3 or 4 gems in. So, but then you're talking about luck. But from this is just statistically speaking how many gems statistically you'd have to use for each gem to work. So, without further ado, I'll show you how this works. Okay, so we're gonna be using X's and O's. They're not for kisses and hugs. They work as O is a success chance, and X means you broke it. So, I'll show you. First gem always works, so that's a 0. And then we're gonna have it break on the first attempt every time, because that is statistically speaking what's gonna happen. Of course it can work on that time, but for it to be 100% certain, I'm gonna show you here. It works on the first one, and then it breaks on the second one. Then you have to start from scratch. It works on the first one, and then it works on the second one too. To show you a little better how we're doing this. God damn it, where is it? Hello. Okay. It's kind of like flipping a coin here, because if it has 50% chance of working the first time and a 50% chance of working the second time, statistically speaking, the two times here will make up 100%. You could say if you flip a coin 2 times, you have, in theory, a 100% chance of getting that one side of the coin at least once. It's like playing roulette, but without the green area there, because that makes up a difference. So let's say there were 50% black and 50% red. So if you play 1 time, that means you have a 50% chance of it working. But if you play 2 times, it means, in theory, statistically speaking, mathematically speaking, that you'd succeed. So 2 times means success. So that's what we're doing here. 50% chance the first time, 50% chance the other time equals 100% chance. So you'll always look at what happened the last time. I'm going to show you a little more clearly here. First, I'm going to remove these numbers, and you can write it up as you go. 2 gems equal. Shut up, it's late. Too lazy to rush the keyboard. To get 2 gems to stick, you had to use 4 gems. Do you see here? You got 2 to stick here. How many did you use? 4. So, to get 2 gems to work, you spent 4 gems. So, what you're doing here is that now we're going to calculate it further. We're going to try for a 3rd gem. It breaks because, like I said, we'll have it break every time the first time. So then you're from scratch. And no, you can't do it like works on the first one, works on the second one, and then works on the third one. That's not how it works, because you need to do each phase again. So you'll be at scratch here. And then you have to look what happened the last time you did it. Since it takes turn working, if you get it. Let's show you here. statistically speaking, that's, well, get it? Statistically speaking, that's how it would go. It would break, work, break, work, break, and so on. Every other time it would succeed, and every other time it would break. So you have to look at what happened the last time. So the first one always works, so that's the exception. Then the second one, then you have to go up and see here. What happened the last time you tried to put the second gem in? It worked the last time. That means since it's every other turn of it working and breaking, means since it worked the last time, it must break this time, statistically. So then you're on scratch again. Then first one in, and then you go up and see what happened the last time you tried for 2 gems. It broke. That means the second time it works. Now you're at 3 gems. Now you have to go up and look what happened the last time you tried 3 gems. It broke. That means, statistically speaking, it works this time. So then you have successfully slotted 3 gems. So then you have 3 gems. I do not want to look at the keyboard. I'll just try every combination first. There we go. To get 3 gems in, you have to spend, let's see, you spent 4 at this point, then you have to count this one. So it's 5, 6, 7, 8, 9, 10. 10 gems. Statistically speaking, it took 10 gems to successfully slot 3. And of course, you could do it, you could get 3 gems in the first try, meaning you only spent 3 gems, or you can get it in the second try, meaning you only spent 5 gems. So that's just luck or unluck, because you could spend 100 gems and not get 3 in it. Statistically speaking, 10 is the number to get 3 in. And then you just continue it like this. I'll show you a couple further. So we're gonna try for a 4th gem here. And the first time we'll have it break. So then you start from scratch again, because you have to redo everything you've done. So here you go with it works the first time, and then you go up and look as always. It worked the last time you tried for number 2. That means it breaks here. Next, it works, and then you go up and look. It broke the last time. That means it works this time. And then you try for a 3rd one. What happened the last time you tried 3? It worked. That means it must break. Then you start over again. It works. And then what happened last time? It worked. That means it breaks. It works. And last time it broke, so it works. Last time you tried with 3 gems, it broke, so it works. The last time you tried with 4 gems, it broke. That means it works. Now you have 4 gems in it. And that's how you calculate it. 4 gems. Oh, not that many tries. So then you have 10 here. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 gems. So, statistically speaking, to get 4 gems to slot, you need to spend 22. Mathematically. To short, because this is a process that it repeats itself for each step. Every time you go from 2 to 3 to 4, you have to repeat what you did before. So if you wanted to cut down a process, you could simply copy paste what you did. I'll show you. Let's say you wanted to try for a 5th gem here. That means it will break the first time. So what you could do here is I'm gonna remove these because they would be in the way of the copy paste. What you could do here is that you copy these and then you paste it here, and instead you just rewrite that last one because this is for everything that happened. No, that's wrong. So this way you can make it go very quickly. Now you have 5 gems in it, then you try for a 6 gem, it breaks, copy it all, paste it, and now because it failed the last time you tried to put in 6, means it works the second time you try to put in 6, so 6. And I think the pieces I've seen, the maximum amount of gem slots has been 7. I haven't seen any with 8 yet. Maybe it exists. I don't know, at Mythic Ironheart or Mythic Tier 7s. Maybe they have that. I'm not 100% sure, but I've only seen up to 7, so I'll calculate that far. Let's see here. Forgot a little what I was talking about. Yeah, so last time you tried with 6 gems, it broke. So it works here on the 6th one. And to get 7, see, you try for 7 here, then it breaks. Do the same again. You copy paste it. And this would be the full amount to get 7 gems. Well, I forgot to change it here because it works this time. This is 7 gems. And then you can count how many signs are in this. I'll pause and do that now. Okay, so I've been counting, and it's, if I'm not mistaken, and it is 6 AM here, so I could be. But I count 94 gems to get 6. 94 gems equals 6. This is how far we've gotten here, and then it broke on the 7th. So since you're duplicating the process, you should just be able to double the amount and plus 2, because we wouldn't. It would be 95 if we counted how it broke there. So I guess we can do that, and so it's 95 here instead. Duplicate the process and have that number. So 95 plus 95 is 190. So for 7 gems, that is fuck you, 190. As you can see, 6 gems is 94 gems, means you get 6 slotted, and 7 gems be, or no, 190 gems. I'm sorry, it's 6 in the morning. 94 gems statistically means you get 6 slotted, and 190 gems statistically means you get 7 slotted. And this is the process you do to calculate it, and I think it is 100% accurate if we go out from the 2 rules as I mentioned. The first gem always working, and all the other gems have a 50-50 chance of breaking or succeeding. So yeah, this is how I would calculate exactly how many gems you statistically would spend, going from 1 gem to 7. And I showed this to Platten, and he showed me something I had forgotten, so I remade it, and we both agreed that the new spreadsheet, or the new calculation we had, was correct. So this is what I'm showing you now, the correct version, because I had it slightly wrong the first time. He saw a flaw that I didn't see. So after that little correction, it was, I would say it's perfect as it is now. So yeah, 7 gems, statistically speaking, 190. So yeah, I'd say this is the most accurate you can get it, because as you can see, it's very logical. It is really logical, I'd say. Every other every other time it works, because 50% chance. So I'd say this is. And if I was good with, or I'm sure it's not hard to get onto a spreadsheet, but um, I'm just too lazy to do it. But if you were gonna make a spreadsheet out of this, you should make it show that this that all the I would make different rows here, because the first one here always works. Then you do the second one like these. These have to be every other. That's the easiest way to do it. As you can see in my calculation, that's exactly how it goes. It goes break, success, break, success, break, success, break, success, and these are all in row 2. Then you'd have row 3, which is break, success, break, success, and so on. And then you have row 4, success, break, success, break, and so on. Because that's something that always is consistent. So if you make a spreadsheet out of this, just make it into the amount, a bunch of rows here, like 7 or 8 rows, and show that it works every other time. It will go XO, 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 XO on the second row, and it will go XO, XO, XO on the third row, and so on and so on. So it is it's a very simple way to calculate it, I'd say. Um, it just looks complicated with all the X's and O's, but as you can see, it really is just every other time. XO, 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 and then on the third row, XO, 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 XO. So, as I said, very simplistic, but I think it's the most accurate way to do it. So yeah, next time you're trying to get 6 gems into a piece, you have an estimate of how many gems it would cost you. And again, you can be super lucky and do it in only 6 gems, so you can be super unlucky and you need 600 gems. That's just RNG for you. This is statistically what's most likely. 50-50. So yeah, I hope you learned something from watching this video, and uh, hope it didn't depress you too much to see how many gems you could statistically expect to use to fully gem a piece. Uh, but yeah, it's how much honor is this? Let's see. Looking for a calculator. I think it's 770. At least for focus gems, which is what I buy the most of. I'm not 100% sure if that's the same for resilient and toughness. I think it is. So it's 770 times 190. 146,300 honor. Ooh. Yeah. Did that make you sad or what? Statistically speaking, you'd have to spend 146,300 honor to get something fully slotted, to fully gemmed. That's a huge amount of honor, and but again, a bunch of people do it with way less honor, and a bunch of people do it with a lot more honor, like me. Mm, so yeah, these are just statistical numbers. They don't need to mean anything. So yeah, maybe you learned something, and like the video if you think this is the correct way to do it, and I didn't totally lose you here if you feel I explained it alrighty. So yeah, thanks for watching.